I want to do a bit of a different video today, so I want to talk about these three topics here. So the AI stack versus the software tech stack, how we can improve the determinism of LLMs. So I want to do some experiments, testing out different things we can actually do to improve this. And I want to take a quick look at hallucinations. Is that a bug? Is it a feature in generative AI? So yeah, let's just get into it. This video was sponsored by Hubspot. Okay, so this is kind of my idea of how I kind of look at the AI tech stack versus the software tech stack. You can see I have put down non-deterministic and deterministic. So this is kind of my idea of how I think about the differences between these stacks, because in the software tech stack, it's very easy and it's reliable and it should be deterministic. Like if you run the same code 10 times, you would expect to get the same result every time, right? That is kind of not the case when we are using the AI tech stack, especially when we are involving LLMs, right? There are things we can do to improve this, of course, and that could be like a vector database. This could be like an LLM orchestrator. We have some parameters we can change. But basically, in my head, when I'm operating with the AI tech stack, I'm thinking more in this deterministic, non-deterministic mode, right? And that is what's kind of new, I guess, to software devs working with this stack, because it's not so easy to get the same results every time. But I just wanted to dive a bit into kind of how we can improve this. Can we? I'm not 100% sure, but there are some things we can do. And one of the things is like mixing this together. So I have some examples of that. We're going to take a look at that. But yeah, basically, if you want to pause here and read kind of what I think about this, you can see we have the model providers, we have the front-end dev here on the software tech stack, some key trends I put down. So maybe tool development, AI agents, emphasis on cost reduction and efficiency. And basically, these tech stacks, of course, mix together. But I think kind of the differences, or what sets it apart, is for me kind of the non-deterministic versus the deterministic outputs, right? So I kind of wanted to dive a bit more into that and take a look at, can we create some experiments that kind of shows that we can actually improve this deterministic side of LLM outputs. So you can see we have a math problem here. It's a kind of big equation here. And if you have played around with these LLMs, you know they are not very good at solving math problems, especially when they get a bit complicated. I guess maybe the best foundation models now have gotten quite good at it, to be honest. But we are going to do some experiments here with just a very small open source models. So that's going to be Phi 3. I think the first test, we're just going to run this equation, trying to solve it with the temperature or the softmax set at 1. And then we're going to move on to 0. I'm going to explain a bit what is actually the difference when we are setting our temperature to 1 versus 0. How does this affect our determinism of the output? And I think we're just going to run it to GPT-4, looking at the foundation model, see what kind of result we get that. And we're going to do like a combined of the stacks. So we're going to do like a side of the LLMs tech stack, and we're going to mix it up with using some more deterministic software stack, maybe like just like a straight up Python code. So we have some other things we can do to improve the determinism too. That is kind of improve our prompts. We can add context, grounding. We can do a system message. We're going to look at seeds. That is very interesting from OpenAI. And fine-tuning, I'm going to skip it now, but that is also something we can do to improve our deterministic outputs when using LLMs, right? So the first thing I want to do is just run a straight up deterministic answer to this equation. So we're just gonna run a Python code to calculate this and look at the result. But first, let's just take a quick look at today's sponsor. Are you running a startup? Are you planning to start a startup? Well, take a look at this. Do you know how AI is revolutionizing the startup world? Well, to make this easier to understand, Hubspot has created a free ebook called How AI is Redefining Startup GTM Strategy. It's a must-read for any startup that is looking to harness the power of AI to skyrocket their growth. One section that really grabbed my attention was the most popular AI tools for GTM and best practices for scaling section. The ebook looks at how to build an AI-charged tech stack that can take your startup to new heights. And the subsection, What's in an AI-charged startup tech stack, breaks down the most game-changing AI tools out there, from ChatGPT ChatGPT to HubSpot's very own AI-powered suite. But what sets this ebook apart is that it doesn't just list tools, it provides a clear, actionable framework for choosing the right AI solutions for your specific needs and integrating them seamlessly into your existing workflows. Imagine being able to automate repetitive tasks, personalize customer instructions at scale, and uncover hidden insights into your data, all with the power of AI. That's the kind of competitive edge this ebook can help you achieve. So if you are ready to take your startup strategy to the next level with AI, you don't want to miss out on this ebook. Just click the link in the description to get your free copy today. A big thanks to HubSpot for sponsoring this video. Now let's get back to the project. Okay, so here we are kind of operating on kind of the traditional software stack. We want to do some equations using Python. We want to calculate this equation here. We're just going to start by importing math, right? And let's comment out that, and we set this up here. We want to run this, and we want to print the result, right? So when we run this now, right, we get this result, 116.95. But every time we run this now, we're not expecting to get a different result, right? We want to get this every single time, and that is the deterministic route, right? But let's see what happens now when we use our phi model with the temperature set to 1 to actually try to do this. Will we get the result, same result every time? Let's take a look. Okay, so here we have a simple function that runs Llama. We're gonna set our model to phi3, right? We have a system message, we have a user into a query argument. So let's change our temperature to 1 here, and let's go down here. So we're gonna run this with phi3 temperature 1, right? And yeah, we're gonna just feed in the system message, you are a helpful AI assistant. We're gonna feed in our equation here, that is the prompt, right? And we're gonna run that in here, and we're just gonna print the answer here, right? So let's see now when we run this a few times, will we get the same result every single time? So let's run this the first time. Now you can kind of see this is gonna take a bit more time because we are running this on our local computer, but it's a pretty fast model, right? Okay, so you can see the first result we got was 72.34. That was horribly wrong, right? It tried to do some calculations here, but yeah, it kind of failed big time. Let's run it again. So remember, it's 72.34. Let's try again. Now we got 117.01. Let's do one more time. Now we got 147.47. So you can see this is going nowhere. And now we got minus 914. So this is all over the place. We can't really use this for anything because this is way too unreliable to do anything with. But let's see what changes now when we actually change the temperature from 1 down to 0. Okay, so let's just go in here. Let's set this to 0 and let's see if this improves anything. Yeah, let's clear that and let's run it again. Okay, so the first run we got 115.9. That is not correct. But still, let's see if we get the same result again now. 115.89, 115.89. Let's do it again. 115.89. So you can see now we got, at least we got like a deterministic output. We almost got the same, exactly the same output every single time. Okay, so we got it again. So you can see what a big difference that made just changing our temperature from 1 to 0. The answer is wrong, but at least we got some consistency in our output, right? It wasn't all over the place. So yeah, let me just explain a bit what is exactly happening here when we change the temperature from 1 to 0. Okay, so the best explanation I have seen for temperature and softmax is this video from 3Blue1Brown. I'm gonna leave a link in the description to this video. You better watch this if you're into transformers, deep learning and stuff. This is a great video to explain everything what is happening inside an LLM, right? But if you look at his example here you can see the temperature is set to 0, and we have another example where the temperature is set to 5. And we have this example. Once upon a time there was a right, with two different temperatures. And in the first case, when the temperature is 0, you can see 100% of the time here we're gonna select the word little from kind of the probability standpoint, right? But here we kind of spread out the probability of what word we're gonna select next. And you can see little has a 6% chance of being selected, but young also has a 6% chance, and great, princess has a 4%. So here any kind of word can pop up because it's so widely spread out, right? And this temperature setting is kind of what makes LLMs more creative more diverse writing, if you want to think of it like that. But that's not always a good thing. Let's say we want to do some math. We don't want random things happening right in the output. So what I say, like for math equation and stuff, you better put the temperature quite low if you want some kind of determinism. But just listen to this for a bit. I think it's very interesting.
Some situations, like when ChatGPT is using this distribution to create a next word, there's room for a little bit of extra fun by adding a little extra spice into this function with a constant t thrown into the denominator of those exponents. We call it the temperature since it vaguely resembles the role of temperature in certain thermodynamics equations. And the effect is that when t is larger, you give more weight to the lower values, meaning the distribution is a little bit more uniform. And if t is smaller, then the bigger values will dominate more aggressively.
Yeah, so you can see here when he increases the temperature, the probability of something being selected is more spread out. But when we decrease the temperature, like the bigger ones is gonna be selected always, right?
Where in the extreme, setting t equal to 0 means all of the weight goes to that maximum value. For example, I'll have GPT-3 generate a story with the seed text, "Once upon a time there was A," but I'm going to use different temperatures in each case. Temperature 0 means that it always goes with the most predictable word. And what you get ends up being kind of a trite derivative of Goldilocks.
Yeah, so that was kind of what I was talking about. So it can be very general, very boring, and maybe very related to the training data, right? But here when we change up the temperature, it could be more creative, feel more, yeah. Let's hear what he has to say about it.
A higher temperature gives it a chance to choose less likely words, but it comes with a risk. In this case, the story starts out a bit more originally, about a young web artist from South Korea, but it quickly degenerates into nonsense.
Yeah, so here it was too much of a spread, right? So it doesn't even make sense sometimes because it's so far from selecting the word that makes sense. So that is interesting.
Technically speaking, the API doesn't actually let you pick a temperature bigger than 2. There is no mathematical reason for this. It's just an arbitrary constraint imposed, I suppose, to keep their tool from being seen generating things that are too nonsensical. So if you're curious, the way this animation is actually working is I'm taking the 20 most probable next tokens that GPT-3 generates, which seems to be the maximum they'll give me, and then I tweak the probabilities based on an exponent of 1/5.
Yeah, so I kind of think we get it. So yeah, a very good explanation. Also this visual component here. So yeah, go check out this video. It's in the description. Okay, so now we kind of know what the temperature is. Let's take a look at what we have so far. So we were on the test with Phi3 with the temperature set to 1. We got all over the place, like different results. We set it down to 0. We got the same result every single time, but it was wrong, right? This is the correct answer. Now let's move on to running like a very new big foundation model and see if this GPT-4o model can solve this. And then use Phi3 again, and let's add some deterministic software to help it, right? And see if we can solve it. So let's do the GPT-4o test now. So let's just swap out this with the GPT-4o with no Python code. Let's just do, yeah, the same. And let's run it and see if we actually can get, if we can solve this without any extra help. The temperature should be set to, let's set it to 0 now because we know that's the best way to do this. Okay, so let's clear this. Let's run it. Okay, so you can see here the answer is 116.95. That is correct. So yeah, good job by the GPT-4o model here. Let's run it one more time just to be sure. Remember, we have the set the temperature to 0, so we should get exactly the same output, right? Yeah, perfect. So yeah, that means with the bigger foundation models, we can actually solve this equation by just running it through kind of the AI tech stack without adding any additional tools, right? So yeah, GPT-4o solved this correctly, but now let's take a look at our final test. So this is going to be the Phi3 model that didn't solve this, but let's add in some extra help here by combining this with some deterministic software here. So let me just show you how I set that up. So to solve this, we want to do it in a bit different way. We want to start with creating a code prompt. So we're going to feed in our equation here into this prompt question. It's going to be equal to our prompt, right? This is our equation. And from the question above, generate a Python code to solve the equation. Okay. So we're going to run this with Ulama chat. We're going to try to generate a Python code. And here we're going to switch up our system message. So we're going to use an expert at writing correct executable Python code. Don't use any extra explanation of text. Write pure executable Python code to solve the problem. Okay, so we're gonna generate a Python code to try to solve this equation. We're gonna clean it up with a simple function here, just to remove some stuff here to make it executable. And then we have a function that actually executes our Python code. And then we're gonna print the result. So remember, we are still running the phi3 model. We can set the temperature to 0 first. Let's try it with 1 first. And then we're going to change it back to 0 and see if that makes any difference. So yeah, hopefully this will give us a more deterministic output and hopefully solve the equation. Okay, so let's run this. So this is with the temperature set to 1, right? Yeah, so the result is correct. So you can see we imported math. We run the result and we have the equation here. And we just run this using phi3 combined with a Python code. And yeah, perfect. So that was correct. So I'm pretty sure like if we switch up the temperature to 0 now, we're also going to get this correct. But let's just do it. So let's set that to 0. Let's run it again. We might actually change up the input a bit. Yeah, you can see it's a bit different, isn't it? I don't know. It looks pretty similar, to be honest. I guess we got print result here instead. But other than that, yeah. So here you can kind of see the advantage of adding like mixing up like with the traditional software stack, mixing that with the AI stack, the LLMs, and using this as tools to kind of get a more deterministic output. So when we combine phi3 with a tool, we could actually solve this, right? Because we use the phi3 model to just generate the code we needed, and then we can just execute on that code, right? So just to sum this up, you can see with using the deterministic, just the Python code, we solved this easy, right? With the temperature set to 1 using the phi3 model, we couldn't solve it. Same here with the 0 temperature. But when we run the bigger foundation model, we can solve the equation. But then we can use the phi3 model, the open source model, and add some deterministic software, like just a simple Python code, feed in our equation, and then we actually solved it. Finally, I just wanted to take a quick look at some other things we can do to improve determinism. But yeah, I think we're just going to look at the seed part now. Maybe we do some other stuff with context and stuff in another video. I don't want to drag this out to 45 minutes. But let's take a quick look at the OpenAI solution to this. They have this something called Seeds. So let's go over there, take a look at that and how we can actually use it. Okay, so if we go into the API docs for the OpenAI chat completion, you can see we have this option here called Seed. This feature is in beta. If specified, our system will make the best effort to sample deterministically, such that repeated requests with the same seed and parameters should return the same result. Determinism is not guaranteed, and you should refer to the system fingerprint response parameter to monitor the changes in the backend. So this is kind of their attempt of trying to improve determinism in these LLM outputs. But let's now kind of take a look at how does this work? Does it work? And how does this compare to just a regular chat completion request? So I went over here, I created some implementation of this. So we see we have the function here that has included the seed parameter. So seed equals seeds, and we're going to feed this in as an arg here. So we're going to set our seed value just to a random number, 69. And we have a second function that does not use the seed. Both temperatures is going to be set to 1, and we're going to feed in the same prompt. What is the best pizza in New York? Like with a lot of cheese? Only list the one top place, please. And we're going to run this like in 2 requests here. One with the seed and one without. And let's see if we can see if like the first answer here is more deterministic than the second one. So yeah, let's just fire this up and see yeah, if it works. Okay, so let me just run this a few times now, and then we can kind of compare the result to see if we can see any differences in using the seed and not using the seed. Okay, so I think we had some good results here. So you can see the first one here is always where we use the seed. So the best pizza in New York is often cited to be from the Farah Pizza in Brooklyn. And you can see here is just the other request without the seed. The best pizza in New York is often said to be. The best pizza in New York is often considered. The best pizza in New York is often attributed to. The Farah Pizza is Brooklyn's widely regarded. So this produces a different result every single time. But you can see where we use the seed, we get the same output every single request here. So it seems to be working, but like I said, it's not a guarantee. And my thinking is if we expand the prompt, we want like a long result. This is probably not going to hold up, but we're probably going to check that some other time. But for this simple answer here, it looks to produce the same output every single time. So at least that's something we can do to kind of improve our deterministic output using LLMs, right? So this could be an interesting feature to try out going forward, right? Okay, just to wrap this up, I think we kind of proved today that we can do something to improve the deterministic outputs of an LLM. But probably as you already know, that these are not designed to actually be deterministic. The way they calculate or the way they use the neural network to kind of come up with a probabilistic answer or the next sentence or the next word or the next token. So by nature, these are not tools created to be deterministic because they are generative. If they were 100% deterministic, then yeah, what new stuff could they create? Could they create an image? Could they create a new kind of text? I don't think so. That would be just reciting the training data. And without that hallucination part of it, I don't think these LLMs would be that interesting. But of course, some use cases are heavily reliant on that we can reproduce the same output and be precise, right? So I think these big companies are working, like with OpenAI and the seed part, they are working on making these models much more deterministic. We can add context, like we said, we can add different tools. So going forward, I think we're going to see these tools pop up more to kind of get the outputs we are expecting. We've seen this with RagWrite, adding grounding, improving at prompts, system messages. All of these tools are to reduce hallucinations, right? But if you think about it, is it a bug? Is it a feature? I'm leaning more towards that these hallucinations has to be there if it's going to be something interesting coming out of these models. But in some cases, like we saw with Google last week, it's not going to work every single time. But yeah, we just have to wait and see what happens in this space when it comes to these problems with hallucinations and stuff. But yeah, that is just kind of my take on it. A bit of a different video today. Hope you enjoyed it. Other than that, thank you for tuning in, and I'll see you again on Wednesday.